Hello everyone, welcome back to the linear algebra series. In the last lecture, we looked about what are bases and what happens to a vector when we change the basis. So now in this video, we will look more about what are bases and what is linear independence. So basis is a set of n vectors that are not linear combination of each other. That is, they are linearly independent. They span the space. The space is then n-dimensional. Okay. So usually whenever we see any example of vectors, we see that the basis vector are either perpendicular or they are unit vectors. Okay, but this need not to be always the same scenario. You can have basis vector which are not unit vectors, which are not perpendicular to each other also. Okay, so this is just to ease the mathematical operations or to for make the examples more simpler. So now let us look what is linear independence. So for example, we have a vector b1. So this, by taking multiple of b1, we can get anywhere in the 1D space. Okay. And same way, if we have another vector b2, and with the help of b1 and b2, we can, in a particular plane, we can reach to any 2D space. Now, if we take another vector b3, for b3 to be a basis vector, it has to be impossible for us to find some value of a1 and a2 such that b3 is not equal to a1 b1 plus a2 b3. That is, with any there should not be any case where with the combination with the help of these two vector we can form the vector b3. Okay, so if there is no such scenario, we can say that b3 is a linearly independent vector and it can form a basis vector. Okay. Now, last time we looked about what happens when a basis vector changes. Okay, so how do it actually looks in the graph? So, for example, if you look at this particular graph, these black lines are the old basis vector, and the straight and the vertical and horizontal line are the other the basically the grid in the previous basis. Okay, so when the basis vector changes, you can see the new basis vector are the red ones. So it has moved little bit. It has made a 45-degree turn towards the left, and same way if you see all the grid which are like bit diagonal, they also made around 45-degree angle change. So whenever the basis vector are changed, the grid are evenly spaced, but they might be little bit tilted. Okay,